This is a short video doing some differentiation of a quotient without actually using the quotient rule. So here's the question that the person's asked. So they've looked up some work solutions in their textbook, and they're just wondering, how did the person writing the solutions go about arriving at this derivative? So have a look, see if you can figure it out. All right, so we'll check it out. So the question was probably something like, hey, determine f dash of x if your function is as follows. So there's a few ways that you could go about doing this problem. One way would be seeing it as a quotient, saying, hey, this is u, this is v, and then going into your big nasty quotient rule and having to do a lot of work around fractions. Okay, we're going to avoid doing that altogether. Instead, what we're going to do, we're just going to look at this fraction and think, hey, those three terms on the top, I want to divide all of them by the denominator. Okay, so if you want to think of a different example, you can think, say, I've got 8 plus 10 plus 4, all divided by 2. That'd be the same as 8 divided by 2 plus 10 divided by 2 plus 4 divided by 2. Okay, we'd get the same result as if we did the top line by itself. Okay, we'll get 11 in both ways. Okay, so we are allowed to divide each of these terms by the denominator. So we'll go ahead and do that. We'll grab the first term, divide it by the denominator, grab the second term, divide it by the denominator, and grab the last term, and also divide it by the denominator. So we'll be able to do a bunch of cancellations. So cancel, cancel gives me 2. Cancel, cancel gives me negative e to the power negative x. And I can't really do any cancellations there. I'll just make it a negative power so I can differentiate it in the future. So just like the text did, I'll look at it half and e to the power negative 2x. So notice that I haven't actually done any differentiation yet. All I've done is just changed what the function looks like. Okay, so from here, it's all in a form where I can differentiate it, because I'm happy with differentiating e to any power. I'm not happy differentiating, like if I left this one as negative 1 on e to the x, I'm not happy differentiating that. I don't know a rule for that. I'd have to use chain rule again. So I just want them all in that form with e's on the numerators, and now I can go ahead and differentiate those three terms. Okay, so differentiation of a constant is 0. Differentiate this guy, so it stays as e to the power negative x, and multiply by negative 1 for quotient rule will give me a positive. And do the same thing here, so it stays as e to the power minus 2x, and multiplication by negative 2 will give me negative 2 times positive half, which is negative 1. Okay, so you'll see that this derivative is effectively the same as the one that the textbook got. Okay, so exactly the same as here. The only thing the textbook writer did was probably saw that 2 and knew that it was going to differentiate to 0, so they probably just accidentally forgot to put it in there, but it should definitely be in there in the work solutions. Okay, so strategy is always, hey, I'm looking at something that I don't know how to differentiate. I can use the quotient rule, or I can change it into a function that I easily know how to differentiate. Okay, so always look for those opportunities, and good luck.